Dear students, the question number 16 says that inside a neutral hollow conducting sphere of radius x and center C, a point charge q is placed as shown in the figure. Another point charge q1 is placed outside the sphere at a distance d from the center. The net electrostatic force on charge q placed at its center is. Now dear students, we know that for a conductor in electrostatics condition, the net electric field due to the induced charges on the conductor and the charges outside the conductor is zero inside the conductor. Therefore, the net electric field inside the conductor would be zero. And because the net electric field inside the conductor would be zero, the net force experienced by charge small q kept inside the conducting sphere would be zero, and therefore the correct answer for question number 16 should be option number 1. Now let us proceed to the next question, which is question number 17. Dear students, the question number 17 involves a circuit diagram and says that the current in the resistor R3 in this circuit as shown in the figure is. Now dear students, if we see this particular circuit, we see that it is symmetrical about this very particular line. And due to symmetry, the potential of this point and this point would be same. And since the potential of this point and this point would be same, on the similar principle, the potential of this and this point would be same, the potential of this point and this point would be same, and the potential of this point and this point would be same. Now, since the potential difference across each resistor would be zero, there will be no current across any resistor. Specifically across the resistor R3, the current would be zero, and the correct answer for this particular question should be option number 4. Now dear students, let us proceed to the next question, which is question number 18. Dear students, the question number 18 says that consider the following operations related to a capacitor connected across a battery initially. Operation 1 is disconnecting from battery. Operation 2 is increasing separation between the plates, and operation 3 is completely filling up the region between the capacitor plates with a dielectric. The operation sequences after which the energy stored in the capacitor will be greater than the initial energy stored is. So 4 options have been given to us. Let us analyze each option individually. Analyzing option number 1, we can see that the first operation that has been mentioned to us is operation number 1. So in operation 1, the battery is disconnected, which means that the charge becomes a constant. Now dear students, the next operation is operation 3, which means that the capacitive region is completely filled up with a dielectric, which means that the capacitance increases. Now energy can be written as q square divided by 2c. Since c is increasing, the energy would decrease. Therefore, option number 1 cannot be our answer. Now let us proceed and analyze the option number 2. The option number 2 mentions O1 as the first operation. O1 is an operation which means disconnecting from the battery, which again means that charge would become a constant. Now dear students, the next operation is operation number 2. Operation number 2 mentions increasing the separation between the plates. Now we know that since capacitance is equal to epsilon naught A by D, if A remain constant and D is increased, the capacitance would decrease. Now dear students, we can write energy to be equal to q square by 2c. Because the capacitance is decreasing, we can easily write that the energy should increase. So option 2 can be one of the answers. Now let us proceed and analyze the option number 3. Option number 3 mentions O3 as the first operation. Now Option number 3 is completely filling up the region between the capacitor plates with a dielectric, which means that after operation 3, the capacitance would increase. Now, the energy can be written as half C V square. Now, if C is increasing, the energy would be increasing. Dear students, we must acknowledge the fact that operation number 1 has no effect in the answer of option number 3, because after disconnecting from the battery, the energy of the capacitor does not change. So from the final energy would always remain larger in the case of option number 3. So therefore option number 3 can also be the answer. Because option number 2 and option number 3 both are the answers, we should go with the option number 4 as the final and the correct answer. Now dear students, let us proceed to the next question, that is question number 19. Dear students, question number 19 says that there are two concentric conducting spherical shells of radius Ra and Rb respectively. Rb is equal to 2Ra. If the inner shell is given a charge Q and the outer shell is given a charge 2Q, then the potential difference between the surfaces of the shells will be. Now dear students, it has been given to us that there are two concentric spherical shells. On the inner shell, a charge Q is given, and on the outer shell, a charge 2Q is given. The inner shell has a radius Ra, while the outer shell has a radius Rb. We have to find out the potential difference between the surfaces of these shells. Now dear students, since inside a shell the region is equipotential, therefore due to the outer shell, the potential at the inner shell and the surface of the outer shell would remain same. Therefore the potential difference would be only due to the inner shell. We can write it as that the potential difference would be equal to KQ by Ra minus KQ by Rb. Rb can be written to be equal to 2Ra because it is given in the question. So we can write delta V as KQ by Ra minus KQ by 2Ra, which is equal to KQ by 2Ra. So the correct answer for this particular question should be option number 1. Now dear students, let us proceed to the next question, which is question number 20. Dear students, the question number 20 says that among the circuits as shown in the following figures, the glow intensity of any individual bulb will be minimum in. So 4 options have been given to us, and we have to find out that in which option any of the bulb would glow with the minimum intensity. Now we can see in option number 1 that the net potential of the batteries combined is 2V, and these 3 bulbs, because they are identical, would have a potential difference of 2V by 3 each. That is 1/3 of the total potential difference. In the second option, the net potential of the batteries combined is 2V, and because there are 2 bulbs, the potential difference across the each bulb will be equal to the net potential divided by total number of bulbs, that is 2, which is equal to V. In option number 3, the potential difference across the both bulbs combined is V, and since these 2 bulbs are identical, the potential difference across each bulb will be equal to V by 2. Now dear students, in option number 4, both bulbs have same potential difference because they are in parallel. The net potential of the batteries combined is equal to 2V, and the potential difference across both the bulbs is equal to 2V. Now dear students, we know that the power dissipated through a bulb can be written as equal to V square by R, where R is the resistance of the bulb and V is the potential difference across the bulb. So the case in which the potential difference across the bulb is minimum would be the case where the bulbs will be glowing with the minimum intensity. So comparing all the 4 options, we can see that in option number 3, the potential difference, that is V by 2, is minimum as compared to any other option. So in option number 3, the bulbs will grow with the minimum intensity as compared to any other option. Now dear students, let us proceed to the next question, which is question number 21.